Section 1.6 is inverse functions. So let's look at this today. It says inverse functions, sorry, the top is cut off a little bit. Inverse functions reverse the function's process. They allow us to find the original input value if we know the output. So normally we have an equation that looks something like this, f of x equals 2x minus 3. And we put in our x values, or our input. Let's go ahead and use -2, -1, 0, 1, and 2. So if I plug -2 into this function, I get -7. If I plug in -1, I get -5. 0 gives me -3. 1 gives me -1, and 2 will give me +1. So that's plugging in input to get output. Now I can do this in reverse. I can say, well, what if my output is -5 and I want to find my input? So I would add 3 and divide by 2, and I would find that when my output is -5, my input is -1. But that's a lot of work to do each time, much harder than plugging in an x to get a y. But if I know the inverse function, which in this case, and we'll talk about how we get this in a minute, if I have the inverse function, then if I plug an x value into the inverse, let me put my output values from over here. If I plug -5 in here, I get -5 plus 3 is -2/2, which is -1. If I plug in -7, I get -4 divided by 2. If I plug in -3, I get 0. If I plug in -1 to the top, I get 2/1. Oops, excuse me, 2/2, which is 1, etc. So you can see that what has happened is that these two tables, the x and the y's, have flip-flopped or changed positions. So if I have a function and I plug in an x to get a y, if I know the inverse and plug in x values, the y's that I get will be the x's from the original function. We've flipped our x and y's. So how do I get from here to here? And what does this mean for us? So to find an inverse function, let's again use the one that we had on the last screen. And if I want to find its inverse, one of the ways to do this is to rewrite it as a y-x equation and then switch the x and the y. So if I make the y-x and the x-y, this is going to be my inverse. Now to make it a function, I want to solve for y. So I'm going to add 3 to both sides and then divide by 2. So you can see that y equals x plus 3/2, or the way that we wrote it on the last screen was using my inverse notation. All right, and let's talk about this for a minute, this notation. We have seen before that when we use -1 as an exponent, it means that we're going to take the reciprocal. In function notation, this means that this function is the inverse of f of x. It is a notation, not an exponent. So when you see, and you don't have to put all of this in your notes, it's just a reminder, when you see f of x equals 2x minus 3, that does not mean that f inverse of x is 1/2x minus 3. This is not true. All right, so that's one way to find our inverse function, literally changing x to y and y to x, and then solving for y for a new function. The other way to think of this is that these two functions should undo each other. If I plug in x value into my first function and get out a y, and then if I put that y into the x of my inverse, I should get out the same thing that I put in on the other side. They should undo each other. I should end up back where I started. Remember on our last screen, if I put -2 into this function and got -7, if I plug -7 into the inverse, I'm back to -2. I've undone the operations. So I can find an inverse operation or an inverse function by undoing the operations. If we look at this function, the first thing that happens to x is that x is multiplied by 2, and then the second thing is that it is that we subtract 3. If I want to undo that, I'm going to go in reverse order. I'm first going to add 3, undoing the subtraction, and then divide by 2, which undoes the multiplication. And if we look at our function over here, that's exactly what we did. We added 3 and divided by 2. Okay. I want to look at these two functions one more time on a graph before we move on further. So again, let's rewrite our functions. F of x was taking x times 2 minus 3. F inverse of x was taking x and adding 3 and dividing by 2. So let's graph the top one. This is a simple linear equation starting at -3 with a slope of up 2 and to the right 1. So it looks something like this. And that I'm going to label as my f of x. My f inverse x, to graph it, I'm going to rewrite this as 1/2 x plus 3/2. That's my inverse function, just written in my y equals mx plus b form. So I'm going to go up to 1.5. Oops, sorry. And then use a slope of up 1 to the right 2, up 1 to the right 2, up 1 to the right. Oh, my screen is very touchy all of a sudden. Okay. And I get a function that looks like this. And that's my f inverse of x. Now, one way to tell that we have gotten an inverse function is if we draw the line y equals x. And if they are a reflection of each other, so if they are a reflection over the line where y equals x, in other words, every x value here, this is the order pair 2, 1. Oh, it should be 1, 2, 1. And then we should have over here a point on this graph that is the point 1, 2. So for every point on this graph, my first one, there is a point on the other graph that the x and the y have switched. And visually we can see it as a reflection over that line x equals y. All right, one-to-one functions. A one-to-one function is called, a function is called one-to-one if different inputs also result in different outputs. So if I have two different x values, x sub 1 and x sub 2, and they do not equal each other, then the output from those 2 points will also not equal each other. Every one-to-one function has an inverse. All linear equations, like the one we just did, are one-to-one. It's easiest to see this if maybe we look at a function that is not one-to-one. Let's look at y equals x squared. If I put in a value for x of -2, my y value is 4. If x is -1, y is 1. If x is 0, y is 0. If x is 1, y is 1. And if x is 2, y is 4. So when I have two different x's, I sometimes get two different y's, but if I change the sign, they get the same y. Now this is a function. It's a quadratic function. It looks like this. It does pass the vertical line test for functions, but it does not have an inverse. So this function does not have an inverse function. If I tried to draw a reflection of this over this line, I would get a function that looks like this. This is not a function. It does not pass the vertical line test. Let's look at that algebraically. If I change this to x equals y squared, this would be my inverse. Okay. If I solve for y, I would get y equals plus or minus the square root of x. That means that every input can give me two different outputs. If x over here is 4, y could either be plus or minus 2. So you can see that this is not a function. By restricting the domains, we can find inverses of functions that are not one-to-one. So let's look again at our y equals x squared. If I say that I'm going to just look at this when x is greater than or equal to 0, now my function is just this piece. And now since x has to be greater than or equal to 0, when I flip this and do an inverse of y equals the square root of x, then I'm always going to get a positive solution. So now my inverse, if this is my y equals x squared, my inverse looks like this. It's only half of that graph, and now it is a function. So y equals the square root of x. So if I restrict the domain, then I can get a function for my inverse. We'll talk a little bit more about this in class if that's not quite making sense to you. I know it's hard to get that idea. All right, so let's do a practice example together. Given f of x equals the cube root of 2x minus 3, find the inverse. Now there are two ways to do this. One is rewrite the function so that x is y and y is x. So I want you to pause the video and try that. So we're going to take this equation, the right-hand side, which is my inverse, and solve it for y. So pause the video and see what you can do. Okay, to solve this for y, I first have to cube both sides. So I now have x cubed equals 2y minus 3. I'm now going to add 3 to both sides and then divide by 2. So y equals x cubed plus 3 divided by 2, and this now is my inverse of my original function. The other way to do this, remember, is to try and undo our operations. So I'm going to write down here what has happened to x. The first thing I'm going to do to x if I plug in a value is multiply by 2. The next thing will be to subtract 3, and then I'm going to take the cube root. To reverse these, I'm going to first cube x, then I'm going to add 3, and then I'm going to divide by 2. So let's see what happens. If I take x and cube it, and then I add 3, and then I divide by 2, I did in fact get the same inverse function as I got over here on the left. Depending upon the function, sometimes one way is easier than the other. You just need to play with both of these methods and see which one works best for you. So that's it for our first video.